introduction to Power BI. In the previous session, we completed, we had completed creating and developing our data models, that is in the form of dimension and fact population tables. And we had started with why exactly we should establish the relationship between, the data sets that we have right now, right? So we also saw that what happens if we do not establish any kind of relationship between between the dimension tables and the fact population table, right? So as long as you're using columns from the same table, your visualization will be visible. But once you use the columns from another table, right? So what happens? Power BI cannot populate the visual because there is no relationship, right? Any kind of relationship. And then we had a look at the cardinality or the type of relationship, right? Whether it's a one-to-many relationship or many-to-many relationship or a one-to-one relationship. So in today's class, we will learn how we can establish a many-to-many relationship when we do not have any kind of normalized data. So the assumption that we made, for establishing a many-to-many relationship is that we have normalized data. So what do I mean by normalized data? It means, each of the tables that we want to establish a relationship between should contain unique values, right? When you have unique values and you do not have foreign keys present in either of the tables, you need to create an intermediate table and then establish the many-to-many relationship. But what if you don't have normalized data, right? More often than not, in the real world, you will not get normalized data sets, right? You will have data sets which will have duplicate data sets, right? So in today's session, we will learn how to establish a many-to-many relationship when you do not have normalized data. Okay, so for that purpose, we'll be using an example file, okay, so which I have shared in the WhatsApp group. Please make sure to open that. So we will go through the data first. So we will understand what exactly the data is telling us, and then we will establish the many-to-many relationship. Okay, let me just share my screen now. Yeah. So in this file, there are already two charts present. Okay, so let us come back to the charts in a couple of minutes, but let us learn about the data first. So to see the data, you need not always go to Power Query Editor. Okay, to have a look at the data, you can also use the data view here. Okay, so there are three views in Power BI homepage, right? The report view where you build the visualizations. The data view is where you see the data in the form of tables and also use the DAX functions, right? And the model view where you establish the relationship between data sets. Okay, so you can click on data view now, and your data will be present in a tabular format. Okay, so now we have three tables. In this file, we have three tables. Cars produced, where you have 4 columns in cars produced. Production ID, color ID, produced, and sold. So basically sold is nothing but the year in which it was sold. Okay, so what you can do, we can rename the sold column to year column. Okay, so that we can avoid any kind of confusion. Okay, so please rename the sold column in cars produced table to year. Okay, so there are two ways to rename. One is to right click on the column which you want to rename and select the rename option, or you can double click on the column header. Okay, so please rename the sold column in cars produced table to year. Okay, so here we have 4 columns: production ID, color ID, produced, and year. Okay, in cars sold, again we have 4 columns: color ID, sold, year, and sales ID. And the color table, which has the color IDs A, B, C, D and the respective colors. So color ID A is green, B is red, C is blue, and D is yellow. Now here you can notice that in cars produced table, production ID is the first column here, right? And in the cars sold table, sales ID, instead of it being the first table, it is the last table here. Now, if you go back to Power Query Editor, right? So if we go back to Power Query Editor here, okay, you can click on the home menu here. Okay, you can click on the home menu and click on transform data to go back to Power Query Editor. Let us do that. Okay, I just want to show you an internal bug in Power BI and how you can solve that internal bug, or basically how to resolve that issue. Okay, so you can go to Power Query Editor by clicking on transform data. So here again, you will have three tables, right? Color, cars produced, and cars sold. But I wanted to show you an internal bug in Power BI called as column order bug. Okay, so in cars produced, you can see that production ID is the first column, color ID, produced, and year. The same order was also in the data view as well, right? Production ID, color ID, produced, and year. Production ID, color ID, produced, and year. But in case of cars sold, even though sales ID is the first column in Power Query Editor, or basically in the cars sold table, if you go back to data view here, if you go back to data view and in cars sold table, you can see that sales ID is in fact the last table here. Sorry, the last column here. Okay, so this is called as a column order bug in Power BI. Okay, so even though the Power Query Editor, even in the Power Query Editor, sales ID is the first column, but in data view, sales ID is coming as the last column here. So this is called as a column order bug in Power BI. So how can we fix this issue? So what you can do, we can go back to Power Query Editor. Okay, we can go back to Power Query Editor and deactivate the enable load option on the cars sold table first. Okay, so the first step is to disable the enable load option here. Okay, so we can deactivate the enable load option for cars sold table. Click on continue and click on close and apply. Okay, so now the cars sold table will be removed from the list of data sets now. Okay, so we can only see cars produced and color. Now we can go back to Power Query Editor. Okay, we can go back to Power Query Editor by clicking on transform data option and activating the enable load option. Okay, so basically we'll be reactivating the enable load option for cars sold table. Okay, now if we click on close and apply, so I have right now enabled this option here. Okay, I have reactivated the enable load option for cars sold table and click on close and apply. So we will wait for cars sold table to be loaded onto the model view here now, and basically onto the data model. So now cars sold table will appear here. And if you check the data now, sales ID is in fact the first column here. Okay, so this is how you fix the issue of an internal bug in Power BI called as column order bug. So if you are facing this exact issue, what you can do, you can go to Power Query Editor, disable or basically deactivate the enable load option on the table you are facing the column order bug, okay, in which you are facing this particular bug. Then reactivate the enable load option. Okay, so these are the steps that you need to follow if you want to resolve the issue of column order bug. Okay, now let us come back. Yeah.
Yeah, sales ID in actual data, sales ID is in first column or the last column?
It is in the first column, but in the data view, it was coming as the last column.
Okay, thank you.
Yeah, all right. Okay, now let us come back to our data here. Okay, so yeah, right now we have three tables, that is cars produced, cars sold, and color. Okay, and notice that right now in cars produced and cars sold, we have, excuse me, we have two matching columns, right? One in the form of color ID and one in the form of year column, right? You have two matching columns here, right? When we establish a relationship, the first step is to identify that matching column or the common column, right? But in our case, it doesn't matter which column you select, be it color ID or year. Both have multiple occurrences of each value here, right? So in our case, we'll be using color ID, but you can also use year. But if you select year, you can notice that 2020 is appearing more than once, 2021 is appearing more than once. So that is the same case in cars sold table also, right? 2020 is appearing more than once, 2021 is appearing more than once. But in our case, we will be using color ID as the matching column. Okay. So I will explain why we select the color ID as the matching column. The reason is because if we go back to chart here, so if we go back to the chart here, there are two charts present here, right? There are two side by side, side by side bar chart here. Okay. So in the left chart, you can see that produced is the gray bar and sold is the black bar. But in case of the right chart or the second chart here, sold is the gray bar and produced is the black bar here. Now let us inspect the numbers first. Okay. So both charts are the same here. Okay. Both charts are the same. But the difference is that in the x-axis of the left chart, right, color ID is being used. And that color ID is coming from the cars produced table. Okay. You can see that here, right? So when you select the left chart here, you can see that color ID and produced are coming from the cars produced table, whereas sold is coming from the cars sold table. And in case of the right chart, here also x-axis is the color ID. Okay, there is no change. But in this case, color ID and sold are coming from cars sold table, whereas produced is coming from the cars produced table. Okay. Now let us have a look at the numbers, right? If the charts are displaying the correct numbers or not. Okay. Now let us take D, color ID D as an example. Now here, if you hover to a particular bar, you will get the exact number. Okay. If you hover to any particular bar in the chart, you will get to see the exact number here. Now here, let us inspect the numbers for color ID D. So produced is 9,500. So 9,500 is nothing but the number of cars produced. Okay, number of units of cars. Okay, so number of cars produced for color ID D is 9,500. Now, notice this is for both the years. Okay, 2020 and 2021. Okay, and cars sold is 22,000. Now, this is a little bit strange, right? How can you sell more number of cars if you have produced less number of cars, right? Right now, we have produced 9,500 cars, but we are selling 22,000 cars. Now, if you go back to the data view, okay, let us inspect the numbers in the data itself. Okay, so for color ID D, produced is 9,500 and sold it is saying 22,000. But if you go back to the data view, cars produced for color ID D, 9,500 is correct, right? 4,500 plus 5,000 is 9,500. So produced number is matching. But if we inspect the sold numbers, if you go to cars sold and have a look at the sold numbers here for color ID D, it should be 8,500, right? 4,000 plus 4,500 is 8,500. But in this chart, it is showing 22,000. And that is the same case for the other color IDs as well. Right, so produced numbers are being displayed correctly, but the sold numbers are displayed incorrectly. The reason is because we have not established any kind of relationship between cars produced and cars sold table. Here, the produced numbers are being shown correctly. The reason is because if you notice in the left chart, color ID and produced are coming from the same table. So as long as you're using the columns from the same table, you will get the correct numbers. But the sold column, this black bar here, right? So that particular column is being utilized or being used from the cars sold table. And since there is no relationship established between cars produced and cars sold numbers are incorrectly displayed. And if you come to the right chart, that is the same case, but here the numbers are being incorrectly displayed for the produced numbers or basically the produced bars here. Okay. Now let's inspect the numbers for the color ID A here. Okay. So for color ID A, sold is 2,500. Let us go back to the data view and check the number. So for color ID A, sold is 2,500, which is correct. 1,000 plus 1,500 is 2,500. But here it is saying produced is 26,000. Now this might be a possibility, right? You can produce more number of cars, but sell less number of cars. This might be a possibility. But let us go back to the data view and check the number. If for color ID A and any other color, if the produced numbers are 26,000. So let us go back to data view, go to cars produced and check the number. So it is saying that for color ID A, it should be 26,000. But in fact, the data is saying it should be 3,500, right? 1,500 plus 2,000 is 3,500. But the chart is saying 26,000 here. The reason again, because we have used sold and color ID from cars sold table. So that's why you are seeing the sold numbers correctly, because the x-axis column and the y-axis column are coming from the same table. But the other y-axis, or basically the other bar, is coming from the cars produced table. And since there is no, there is no relationship between cars produced and cars sold, the produced numbers are displayed incorrectly. So now what we have to do, we have to go to model view and establish a relationship between cars produced and cars sold. Okay, so let us go to the model view here. Okay, let us click on the model view. You can,
Anaka,
yeah.
Just a doubt. Okay. Yesterday, we couldn't able to produce an establishment between two datas, but here without an establishment, we could it could able to produce the data. I mean charts. How it is possible?
So there is a settings change here. Okay, so you can go to File, Options and Settings and Options. So here what has happened is, remember in the relationships, you can click on Data Load here. We had disabled this option here. Remember, import relationships from data sources on first load. So right now it is enabled here.
Okay.
Okay, so that is why we are able to see the data here. Okay, even though we have not established any type of relationship, we are able to see the data, but the data is being displayed incorrectly.
Okay, okay, fine.
Yeah, okay. So we can go to model view. Okay, you can minimize this properties pane here. Okay, you can minimize the properties pane. And we can go back to our data and arrange the tables in such a way that cars produced is the first table, cars sold is the second table, and color is the third table, in this way here. Okay. So the first step is to establish relationship between cars produced and cars sold. And in our case, we will be using color ID as the matching column. Now, if you go to the data view here you can see that each color ID is repeated here, right? Or basically color ID A is
sorry to interrupt. How did you get that tables? I mean, how did you
click on the model view here in the left tab, click on the model view. So while establishing relationships, we will be working in the model view, and when we go to the DAX functions, we'll be working in this data view here. Okay, so instead of going to Power Query editor in order to have a look at the data, you can just inspect it using the data view here. Okay. Now, in our case, we'll be using color ID. So in today's class, we'll be learning how to establish a many-to-many relationship when we don't have normalized data. And that is the case for us here, right? Since we'll be using color ID as the matching column, you can see that the values present in color ID is not unique, right? Because A is mentioned twice, B is mentioned twice, C is mentioned twice, and D is also mentioned twice. So they are not unique. And that is the same case in the cars sold table also, right? Multiple occurrences for each color ID. But in case of color table, you have unique values, right? So first we'll be establishing a relationship between cars produced and cars sold. And we'll be using color ID as the matching column. Okay, so we can drag color ID either from cars sold table and drop it on top of the color ID column in cars produced table, or vice versa. Okay, it doesn't matter. So I am going to drag color ID column from cars produced table and drop it on top of color ID column in the cars sold table. Now, as soon as you do that, the create relationship, or basically the configuration window of the relationship, establishing relationship opens up. Here it is giving us a notification here saying this relationship has cardinality many to many. This should only be used if it is expected that neither column. So in our case, automatically it has chosen color ID as the common column. Okay. So this should only be used if it is expected that neither column contains unique values. And that is the case, right? In our case, color ID column in cars produced table doesn't have unique values, and color ID column in cars sold table doesn't have unique values. Okay, so here it has automatically selected the many-to-many relationship. Okay, now I will come to this cross filter direction. Okay, that is the second property of a relationship, right? So the first feature or the property is the cardinality, which is nothing but
how did you go to this window?
Yeah, so basically color ID column is the matching column here, right?
No.
So you can drag color ID column from cars produced or from cars sold and drop it on top of color ID column in the other table.
So we have changed the view.
Yeah, so once you do this, automatically you will be taken to the configuration window of the relationships. Okay, so you'll get this particular window here. Now this window
this automatically pops up, is it?
Yes, exactly. Yes, it automatically pops up. Yeah.
Okay, and how did we create the previous?
This particular view.
I had some streaming.
No issue. So this particular view, right? Yeah, you have to click on the model view here in the left tab. Yeah, you can click on the model view and you can arrange the tables in this way so that it becomes easy, okay, to establish the relationship.
Okay.
Yeah. All right. So you drag color ID from cars produced and drop it on top of color ID in cars sold. You will get these, edit relationship window automatically. Now we have learned about the cardinality, right? The types of relationship, right? One to many, many to many, and one to one. Now let us click on OK. I will come back to this cross filter direction and make this relationship active in a couple of minutes. Okay, I will come back to this. Okay, so you can click on OK now. Now a many-to-many relationship has been established here, right? There is a star symbol for cars produced and a star symbol for cars sold, meaning it is a many-to-many relationship. Okay, now you can go back to report view. Okay, I will come back to this part here, these arrow marks in a couple of minutes. So if you go back to the report view now, the charts have changed, right? So now that we have established the relationship between cars produced and cars sold, let us inspect the numbers, okay, whether it is displaying the correct numbers or not. Okay, so let us take a color ID as an example. Okay, in the left chart, let us inspect the color ID A. So in color ID A, it is saying that produced is 3,500 and sold is 2,500. Let us go back to data view and check. Okay, so produced is 3,500, which is correct, right? 1,500 plus 2,000 is 3,500, and cars sold should be 2,500, which is also correct here, right? 1,000 plus 1,500 is 2,500. So this chart is displaying correct numbers. I mean, you can cross verify it for another color ID. Okay, for example, I chose color ID A. You guys can try it out for B, C, or D. Now let us come to the right chart and do the same thing. Okay, so this time I'm going to select color ID C. Okay, you guys can try it out for any other color ID. Okay, so in color ID C, sold is 6,500 and produced is 7,500. So go back to data view. Sold, it should be 6,500, which is correct, right? 3,000 plus 3,500 is 6,500, and cars produced should be 7,500, which is also correct, right? 3,500 plus 4,000 is 7,500. So now that we have established a relationship between cars produced and cars sold, we are able to see the correct numbers in the charts. Okay, now the charts is this, both the charts are displaying the correct numbers. Now let us go back to the model view and have a look at what exactly that cross filter direction is. Okay, so go back to model view, and to access the edit window, right? So the edit window is where we saw the cardinality, active properties, and cross filter direction, right? So there are three ways of accessing the edit window. The first way is to right click on this relationship line here, right? So when you hover to this line here, it will basically get highlighted, right? You can right click on that line and select properties. Or the second way is to, in either of the tables that you have established a relationship between, you can see that there is an option called as more options, right? The three vertical dots here. Okay, you can select in either table. Okay, you can click on the more options in either the cars sold table or the cars produced table and click on manage relationships. Okay, and in manage relationships, you will be shown the relationships that you have established. And in our case, we have established only one relationship right now. And you can select that relationship and click on edit. Or the third option is to, in the ribbon section, you have this manage relationships button here, right? In the middle. Okay. You can click on manage relationships and you can click on edit here by selecting the relationship you want to edit. Okay. So you can click on edit and you'll be taken to this particular page here. Now, we have already looked at cardinality. Let us look at the cross filter direction. So what exactly is the cross filter direction? So cross filter direction indicates the direction of a relationship between the tables. So what do I mean by direction of the relationship? It means, so if you select this drop down menu here, you will have three options here. Okay, so the first two are called as single direction, and the third option is called as both direction. Now let us explore all these three options one by one. Okay, so in the first option, that is the single cross filter direction, it is saying cars sold filters cars produced. So what do I mean by cars sold table filters cars produced table? It means cars sold table has access, right? Cars sold table has access to the information present in cars produced table. So that is what is meant by cars sold filters cars produced. And in case of the second option, it is vice versa, right? Now cars produced table filters cars sold table. It means cars produced table has access to the information present in cars sold table. Okay, not the other way around. And in case of the both as the cross filter direction, it means cars sold has access to information present in cars produced, and cars produced has access to the information present in cars sold. Now, why is it important to select both here? Now, right now, cross filter direction is set to both. So that is why you can see, I'm going to close these windows. That is why you can see these two arrow marks, right? One is going from cars sold towards cars produced, and the other arrow mark is going from cars produced to cars sold. The reason why we have set the cross filter direction to both is because if you go back to report view, we have used color ID. In the left chart, the color ID column is coming from cars produced, and in the right chart, color ID is coming from cars sold. So let us go back to model view and check what happens if you set the cross filter direction to single, where cars produced filters cars sold. And also we will check what happens if we set the cross filter direction as single, where cars sold filters cars produced. Okay, so go back to data view, sorry, model view. Okay, go back to model view and click on properties. Now let us try the first cross filter direction here, where cars sold filters cars produced. Okay, select the first option and click on OK. Now here, look at the arrow mark here. Right now it is going from cars sold table towards cars produced table. It means cars sold table has access to the information present in cars produced table and not the other way around. Okay. Now, if we go back to the report view, you can see that the left chart, it has basically reverted to the original state where produced numbers are correct, but sold numbers are incorrect. The reason is because cars sold table has access to information in cars produced table. But in the left chart, what is happening? Excuse me. In the left chart, color ID and produced are coming from the cars produced table. So that is why you are seeing produced numbers are displayed correctly. But since cars produced doesn't have access to the information present in cars sold, the sold numbers are displayed incorrectly. Okay, so that is the cross filter direction we set, right? Where cars sold filters cars produced. Filters means access. So right now cars sold has access to the information present in cars produced. But cars produced doesn't have access to the information present in cars sold. So that is why the sold numbers are displayed incorrectly. But in the right chart, both the numbers are displayed correctly. Now, if we go back to model view and change the cross filter direction to the second option, that is cars produced filters cars sold. Now you can see that the arrow mark flips, right? So right now the arrow mark is going from cars produced towards cars sold. And if you go to the report view, now we can see that the right chart has changed. The reason because cars sold doesn't have access to the information present in cars produced. So that is why produced numbers are displayed incorrectly here. Okay, so this is the cross filter direction where you can set the direction of the relationship, meaning which table has access to the information present in the other table. And in our case, we have to set it to both because we are using color ID column from cars sold in case of the right chart. And in case of the left chart, we are using color ID column from the cars produced. So it is important or it is necessary to set the cross filter direction to both in our case. Okay.
Is it possible to manually check the tick mark for the second graph?
What do I mean by the tick mark?
I mean, we are getting the color ID. I mean, some data is coming from the car produced and some data is taken from the car sold, right? So shall we make it reverse? I mean, by manually?
Yeah, you can do that. Yeah, so you can remove color ID. So right now we are in the right chart. But so what you can do, you can remove the color ID here. You can just, you can deselect it here. And what you're saying is you want to use the color ID from cars produced, right? Yeah, you can do that. Yes, you can just drag color ID column from cars produced and place it in the x-axis here. Okay, so now if you do that, you'll be basically seeing the correct numbers here. Okay. But instead, what we can do, right? I'll go back to the original structure here, right? So I'm going to remove color ID from cars produced and have the original here. Okay. Now the reason why this is changing is because of the cross filter direction here. Okay, so let us set it to both now. Okay, so let us set the cross filter direction to both such that cars sold has access to information present in cars produced and vice versa, right? Also, cars produced have access to information present in cars sold. So when you click on OK now you can see that the arrow mark is is pointing towards both the tables now. So now when you go back to report view, you can see that even though in the right chart, color ID is coming from cars sold, you will see the produced numbers correctly. Okay. Now, let us change this a little bit more. Okay. So right now, yeah, sorry, did anyone have a question? Yeah. So if you're done with the question, so please mute. Okay. Thank you. So now here we have set the cross filter direction to both. So now we are able to see both the charts correctly, right? So the numbers are being displayed correctly. Now, what is happening in both these charts is the color ID column is the x-axis, right? But in case of the left chart, color ID is coming from produced table, whereas in the right chart, color ID is coming from the sold table. Instead, what we can do, we can have the color ID from the color table, right? Instead of using color ID from cars sold and cars produced table, what we can do, we can have the name of the color itself, right? In our case, what we had to do, we don't know. Let's say I don't know which color ID, which color is color ID A, which color is color ID B, and so on, right? Now let's say I don't know which color ID is yellow, which color ID is red, which color ID is blue, and which color ID is green. Now for every time I have to go to the data view, go to this color table and check, right? Which color ID is green, which color ID is red, and so on. Or I have to note it down somewhere. Instead, what we can do, instead of having color IDs as the x-axis, we can have the names of the color itself, right? So that would mean that we can avoid, or we will right away know the names of the color instead of the color IDs, right? Instead of going back to the data view and checking which color ID is A, right? So, or which color is, color ID A, whether it's red, blue, green, or yellow. Instead of x-axis as color ID, we can just remove it. Okay, I'm going to remove it from both the charts now. Okay, so what we can do, we can select the left chart, remove the color ID from the x-axis, and instead have color as the x-axis. So drag color column from color table and drop it to the x-axis section in the left chart, and repeat the same step in the right chart as well. Okay, so select right chart, remove color ID column from x-axis, and replace it with color column from the color table. Now here again, we will face the issue of incorrect numbers being displayed here, right? So here, produced is 26,000, sold is 22,000. It's the same for all the colors. Here also you get the same numbers here. Sold is 22,000, produced is 26,000. The reason, because if you go back to model view, we have not established any relationship between color and either the cars produced table or the cars sold table. So the next step is to establish that relationship. Okay, now here we can establish a relationship between cars sold and color or cars produced and color. It is not needed that you establish a relationship between cars produced and color as well as cars sold and color. The reason is because if you establish a relationship between cars produced and color, since the cross filter direction is set to both between cars produced and cars sold, indirectly color table will have access to the information present in cars sold through cars produced table. Now, if you establish a relationship between cars sold and color table will have access to the information present in cars produced table through the cars sold table, because cars produced and cars sold table has a cross filter direction set to both. So it is only needed that we establish a relationship between either the cars produced table and color table or cars sold and color table. Okay. Now I am going to establish a relationship between cars sold and color table. You guys can try establishing a relationship between cars produced and color and check the results. Okay, you should get the same results. Okay, so let us experiment this. Okay, I am going to establish relationship between cars sold and color. Some of you can try establishing a relationship between cars produced and color and check the results. Okay, now which is the common column between color and cars sold? It is color ID. It is the same with cars produced and color also. Okay, so color ID is the matching column. So drag color ID column from cars sold and drop it on top of the color ID column in color table. So automatically it will be a one-to-many relationship, right? Because one is because color ID is unique in color table, right? It is unique. The many because it is repetitive in nature, right? The values present in color ID is appearing more than once. So that is why one-to-many relationship. Okay. Now, some of you try establishing a relationship between cars produced and color. Okay, you should get a one-to-many relationship only. Okay. Now, if we go back to the report view here, you should see that
we got a many-to-one relationship when we build a car produced and car color.
Yeah, one-to-many, many-to-many, many-to-one is the same. Many should be for cars produced and one should be for color.
Yeah, fine.
Yeah, okay. So if you go back to report view now, let us check the numbers now. Okay. So yellow, it is saying produced is 9,500 and sold is 8,500. So yellow was color ID D, right? So if you go back to cars sold here for color ID D, it was 8,500, which is correct. And produced was 9,500, which is also correct here, right? 4,500 plus 5,000 is 9,500. Now let us check it for the right chart. Okay, so let's take green here. Okay, I think green was color ID A. Okay, so here color ID A produced is 3,500 and sold is 2,500. Produced is 3,500 3,500, yes. 1,500 plus 2,000 is 3,500. And cars sold was 2,500. It is also correct here, right? 1,000 plus 1,500 is 2,500. So this is how you can establish a many-to-many relationship when you don't have normalized data, right? Power BI will give you a notification saying that, you know, neither of the columns has unique values, but still you want to establish a many-to-many relationship. Yes, you can do that. But right now we have two charts here, okay? And in our charts, what is happening? Columns from both the tables are being utilized. Right, columns from both the tables are being utilized. So it is important that you set the cross filter direction to both. Okay, so that both the tables will have access to the information in both the tables. Okay, and then we also looked at the cross filter direction. So cross filter direction is nothing but it indicates the direction of a relationship. Right, so which table has access to information present in which table. Okay. So in our case, we have set it to both because we have columns from both the tables being utilized in both the charts. Okay. So it is important to set the cross filter direction to both, or it depends on your requirement, right? Or it depends on the charts that you have built. Okay. Now let us come to the last feature of a relationship that is called as active properties.
One more thing.
Yeah.
Can we have all the three tables in both the charts or in one chart?
Yeah, right now we are doing that, right? So right now we are using the color column from color table, sold column from cars sold table, and produced column from cars produced table.
But I can see only 2 bars.
I mean, the reason is because color is an x-axis, right? The color column is being utilized as x-axis.
Okay.
Yeah, okay. Now let us go back to the model view here and have a look at the, the active properties. Okay, so you can select the relationship between cars produced and cars sold here. Okay, you can right click and select properties. Guys, just give me a minute. Okay, just give me a minute. I'll have water income. So the active properties is basically this option here that says make this relationship active. Now, active properties, what it does, it allows a user to activate or deactivate an existing relationship without actually removing it if not needed. Now, let's say I have established a relationship between cars produced and cars sold, right? We have done that. But let's say I don't need to use this relationship as of yet. Okay, right now, I don't want to use this relationship, but I want to use this relationship somewhere in the future. Okay, let's say I want to use this relationship tomorrow, but without deleting it, right? Without deleting it, because I don't need it right now, right? So without actually deleting it, you can just disable the relationship or deactivate the relationship. So to deactivate a relationship or to disable a relationship, you can simply uncheck the box that says make this relationship active and click on OK. Now, as soon as you do that, you can notice that instead of a filled line here, right? If a relationship is active, you can see that it is a filled line. But right now it is a dotted line here, right? You can see that the relationship line is dotted now. So this indicates that this particular relationship is inactive. Now, if you go back to report view, you can see that the numbers or basically the chart has changed here. Okay, so deactivating a relationship is as good as absence of a relationship. Now, in our case, what has happened? We have established a relationship, but since we do not want to use it, instead of deleting it, we are just disabling the relationship or deactivating the relationship. Now, deactivating or disabling a relationship is as good as deleting a relationship. But in our case, we have not deleting a relationship, but instead we have just disabled it. Okay. Now, to reactivate it again, you can go back to properties and check this box here or select the box that says make this relationship active and click on OK. Now you will see that it will be converted to a filled line. And if you go back to the report view, you will see that you will see the correct numbers now. Okay. So this is basically the active properties of a relationship where you can activate or deactivate a relationship without actually removing them if not needed, right? If you don't want a relationship, instead of deleting it, you can just deactivate the relationship by unchecking or basically, unselecting the box that says make this relationship active. Okay, so we have covered all the features or basically all the properties of a relationship, right? So first we learned about the cardinality or the different types of relationship. Then we also learned about the cross filter direction, or in simple words, the direction of the relationship, right? Which table filters which table. Then we also learned about the active properties, or basically, we learned how to deactivate and activate an existing relationship without actually deleting it if not needed. Okay. Now let us go back to our data, right? Let us go back to our project and establish relationship between the dimension and fact population tables. Okay. So I'm going to minimize this particular file here. I have already opened our file here. So make sure to open our file. Okay, make sure to open the file that we were working with, the dimension table and the fact population tables. Now we have already covered what happens to the visualizations, right? What happens to the visualization when you don't establish a relationship and try to create a chart. So right now we had created a chart of population by year. As long as we were using columns from the same table, we were able to see the chart. But here we have also used the category column from dim age table as a legend, right? So if I remove the category column from the legend section, you will be able to see the chart. Okay, let it populate. Yeah, you'll be able to see the chart. Now, only when I use column from the other table, right? So let's say I want to view it for the region split also. Okay, not only for the years, but also for the regions. Okay, so you drag region column from dim region and drop it in the legend section. Here you will get the same result. Okay, so it's the same result with gender also, and for any column from the age dim age table also, right? So let's say category to the legend section, you will say can't display the visual because we have not established any kind of relationship between the dim and the fact population tables. Let us do that now. Okay, so let us go to model view and minimize this particular pane here. Now our tables will be present here. Okay, so let us arrange our tables in in a proper manner. Okay, so I am going to arrange it in this particular format here. Okay, so dim region, let me take it to the right. Dim age, let me take it a little bit towards the left. Okay, so I will arrange it in such a way that fact population will be in the center. Okay. Okay, fact population will be in the center and it is surrounded by the dimension tables here, like this. Yeah. You can also minimize this because we already have 3 or 4 columns, right? So we can have it this way. Okay. Now our job is to establish a relationship between the fact population table and the dimension tables. Okay, so let us establish the relationship between fact population and dim age table first. So the first step is to identify the matching column. So the matching column between fact population and dim age tables is age group ID, right? So you can either drag age group ID from fact population and drop it on top of age group ID in the dim age table, or you can drag age group ID from dim age table and drop it on top of age group ID column in the fact population table. Okay. So drag age group ID column from either of the table and drop it on top of age group ID column in the other table. So automatically a one-to-many relationship will be established. The reason because if you go back to data view, in dim age table, age group ID is unique, right? 1, 2, 3, 4, 5, 6 till 21. There are unique values, right? But in case of fact population, you can see that age group ID, the values are not unique, right? There are multiple occurrences of each age group ID, right? So one is appearing more than once. Basically all the values are appearing more than once. So that is why it is a one-to-many relationship. One, because age group ID is unique in the dim age table, the primary key. And the foreign key here is also age group ID. So the foreign key is basically appearing more than once here. Okay, so that is why it is a one-to-many relationship. And now when we go back to the report view, remember we had used category column in our chart, but it did not populate. But now that we have established the relationship, you can go back to report view, and now you can see that the chart is visible. Okay. Similarly, let us now establish a relationship between fact population and gender now. Okay, so the common column is right now gender ID, right? So you can repeat the same step here. Here also it will be one-to-many, right? Because in dim gender table, gender ID is unique, right? 1 and 2. There are no repetitions. But in case of the fact population table, you can see that gender ID 1 is repeating more than once, and gender ID 2, let me come now. Yeah, gender ID 2 is also appearing more than once. So that is why it is a one-to-many relationship. Now, similarly, let us establish a relationship between fact population and dim region. Okay, so country ID is the matching column now. Okay, so drag country ID column from fact population and drop it on top of country ID column in the dim region table. Now here what happens? Power BI has detected something. It is saying that neither column here, right? Country ID column in fact population and country ID column in dim region. It is saying that it doesn't have unique values. So in fact population, we already knew that country ID column didn't have unique values, right? Because each country and essentially each country ID were appearing more than once. We already knew that, right? Afghanistan specified more than once.
Sorry to interrupt. I just want to know one thing. We are establishing a relationship between two tables. So only if there are similar values, it can establish a relationship. Why does it always ask for unique values?
No, the unique values, it doesn't always ask for unique values.
No, this is the second time it is asking, right? Earlier in the day when
yes. So I will come back. I will come to that reason. The reason is because so let's say I'm going back to that particular window here. The reason why it is giving us this notification is because in fact population, we already knew that country ID was specified more than once, you know, the values, but it is also saying that in the dim region table, in the country ID column, there are values that are repeated more than once. So we don't know for which countries or for which country IDs the values are repeated more than once here. So that is why it is giving us this particular notification saying that neither column contains unique values. So let us go back to Power Query Editor and have a check in the dim region table for which country IDs there are repeating, there are repeating values. Okay, so you can cancel this. And in the home menu, make sure to click on transform data so that we will be taken back to Power Query Editor. Okay. And let us go to the dim region table. Okay, because that is the table we have the issue now. Okay, so click on dim region table and let us wait for the data to populate here. So I will explain why we are facing this issue here. Okay, why it is saying that neither columns has unique values. Okay. Now we know. Now we know that in fact population table, country ID is not unique because we already know that Afghanistan is specified more than once, India is specified more than once, and so on. But it is also saying that the country ID column in dim region has repeated, repeating values or duplicate values. So let us check for which countries and essentially for which country IDs we have that duplicate data. I mean, we can still go ahead and establish that many-to-many relationship. There is nothing wrong with establishing a many-to-many relationship. But let us check, right? Let us check for which countries, the country IDs are specified more than once. Yeah. So now we can close this here. Now, if you have a look at the table closely, for Azerbaijan, the country IDs are specified twice. The reason because of the region here. Now the reason is because United Nations identifies some parts of Azerbaijan to be in the European continent and some parts to be in the Asian continent. And that is the same case with Armenia as well, right? Country ID 51. you can see that Armenia Europe and Armenia Asia, because some parts are recognized, to be a part of European continent and some parts as the Asian continent. And that is the same case for Georgia as well. Okay, if you have a look at Georgia here, here Georgia, row number 66 and 67. Okay, country ID 268. Here also you get the same issue. I mean, this is not an issue. So this is what United Nations identifies, right? It identifies some. Sorry?
Cyprus.
Cyprus is also specified twice here, is it? Yeah. Cyprus, and then I think Turkey as well, right? If you come down, you can also see that Turkey. I mean, I think Turkey is obvious, right? Because I think everyone knows that Turkey, is in the, Eurasian continent, right? So the western part of Turkey is in the European continent, whereas the eastern part of Turkey is in the Asian continent. But it is also the same case for Azerbaijan, Armenia, Georgia, Cyprus, right? So what United Nations does, it identifies some parts of that particular country to be present in the European continent and some parts to be present in the Asian continent. Now, if you are, if it is a specific requirement for you that you retain this particular distinction, right, where Turkey is a part of Asia as well as Europe, then you can retain this data, right? You can retain this data and establish a many-to-many relationship. But if you're not bothered about, whether Azerbaijan should be in Europe or Asia, then what you can do, you can remove the duplicate values in either the country ID column or the country column. Okay. Now, in our case, let us not bother about whether Azerbaijan should be in Europe or it should be in Asia. Let United Nations and Azerbaijan bother about it. Okay. So what we will do, let us remove the duplicate values now. Okay. So let us not bother about which continent should Azerbaijan be in or which continent should Armenia be in. Okay. Let us not bother about that. So what we can do, we can select either the country ID column or the country column to remove the duplicates, right? Because it is essentially the same thing, right? If you remove the duplicates from country ID column, it will remove the, 31, and it will basically remove the entire row here. So you can either select the country column or the country ID column. Now, how remove duplicate works in Power BI is that right now we have two occurrences of Azerbaijan, right? One for Europe and one for Asia. So the remove duplicates function, the logic, how it works is, it retains the first occurrence of Azerbaijan here, okay, and removes the other occurrence or the subsequent occurrences. So Azerbaijan Europe will be retained and Azerbaijan Asia will be removed. And in case of Armenia, it retains the first occurrence of 51 and Armenia. That is, it retains the Europe region and removes the Asia region. So that is how the remove duplicates works in Power BI or any other platform for that matter. So what it does, it retains the first occurrence, right? It retains the first occurrence and removes the subsequent occurrences. Okay. Now let us remove the duplicates from our dim region table. Okay. Let us not bother about which continent should, each of these countries, be in. Okay. So you can select country ID or the country column. Okay, it doesn't matter which column you select. Okay, I am going to select the country column. You guys can try it out using country ID column. Now there are two ways to remove duplicates. One is to right click on the column and select remove duplicates, or you can select the column, go to remove rows and select remove duplicates. Okay, there are two options now. You can select either of them. Okay. So I have already selected the remove duplicates option. So let us wait for the data to populate. Okay, or let us wait for this step to be applied here. And then we will go back to the model view and establish the many-to-many relationship. And then we'll be done with establishing relationship between our fact population table and dimension tables. And then from tomorrow onwards, we'll be learning about the DAX functions. DAX is basically data analysis expressions. Okay, so it is one of the languages used in Power BI. Okay, so first we will learn about the M language. So it is also another language used in Power BI. So just a brief, description of what exactly M language is and how it works. And then we will learn all about the DAX functions. Okay, so DAX functions is nothing but the predefined codes, that are available in Power BI, which you can use to perform analytical calculations, right? Where you can create new columns, new measures. Okay. So that we will learn in tomorrow's session. Okay. Guys, we can do one thing. Okay. If you guys are running late, you can just hop out of the call because this will take a little bit of time. Okay. So that is what happened in the previous batches also, right?
Yes,
so this particular step,
Amiga, I will leave for the day.
Sure. So the remaining step is simple. Okay. You have to go back to, after this step is complete, you have to click on close and apply. Okay. You have to click on close and apply and go back to model view and establish the relationship between a fact population and dim region. So it will be a one-to-many relationship again. Okay. Then you can save the file. Okay. So that is the only remaining step.
Okay.
Yeah. All right. So, I mean, I will wait for it, but if, if you guys are running late for your office, you can please, leave the call. Okay. So this will take a couple of minutes more. Okay. So that is why I told you that. Anyway, you know the next step, right? The next step is to click on close and apply, go back to model view and establish the relationship between fact population and dim region using country ID as the matching column. Okay, so automatically a one-to-many relationship will be established. Okay, then we'll be done with establishing the relationship between fact population and dimension tables. Okay.
It generally takes so much of time.
Not really. The reason is because I mean, even though we don't have many rows here, the problem is we have already used I mean, we tried setting up the relationship between dim region and fact population. So how Power BI Desktop works is, since it is a free to use platform, generally it takes a little bit of time. Okay, so I think we still haven't established. Now let's do one thing, guys. Okay, we can go ahead and click on close and apply now. Okay, you can click on close and apply, and the load screen will populate here. Okay, we can also wait for it to.
Either we can wait in the query, or either we have to wait here.
Yes, exactly. You're absolutely right.
Anaga, I would request you if you can spare some time on the weekend so that